Hey there, everyone. This is Mystic Fish, and welcome to episode 3 of our Factorio Sushi Spectacular. Last episode, we went over how to compute supply and demand, so tracking how much of each item is on the sushi belt, and then also the demand, how much we want on each item on the sushi belt. So we've got those tracked on the red and green wires, which will propagate around the base. So this episode, we're going to work on actually putting things on and taking things off of the sushi belt. Let's see. I am going to go ahead and just do another little pass through our burner miners to make sure we have the materials we might want for handcrafting stuff. How are we in here? We've got plenty of fuel in these. Okay. Let's come up here. Let's get a half a stack of coal in each of these. And how are we in here? These look all okay. So we might as well just stick another half in here as well. All right. That'll keep us running. I guess we'll make sure that we grab what's out of here just to make sure there's space for everything that we might need. Okay, good. All right, now let's do a couple more things. So I want to calculate how long does it take to get around the sushi belt. So if I were to get on it here, how long would it take for me to ride this and get back to the front? And so that is actually going to be related to the number of belts we have in the system. And the math here is, if you remember, we can get 8 items on a belt. Yellow belts move at 15, can move 15 items per second. And so if we want to know the number of seconds it takes to get around, essentially what we do is we need 2 arithmetic combinators. So we're going to grab the belts, number of belts that we have here. We are going to make, so that is number of belts. If we multiply that per, or let's see, we'll take the belts times 8. That's the number of total items that could be on here. We're going to output x as a temporary variable. Then we take x. We say x divided by 15. And this will be, we'll call this L. This is the latency in seconds, okay? Which says, hey, it's going to take 376 seconds to get around the belt at this point. And so that's useful because that tells us the round trip time of the belt, which we'll use for a couple of things. I'm going to take this, I'm going to put this on the red belt. The red, if you remember, the things that are on the red belt are calculated here at the brain, and they're not involved with sort of like plus minus stuff that happens with things onto and off the belt. So this is a good place to put our configuration variables like that. I'm also going to mark this here just so that we can track this. So we'll say L is the latency, the round trip time of going around. Okay, the next thing that I want to calculate is we know how many items are on the belt. We know how long it takes to get around the belt. And so we can actually combine these two things in order to figure out the actual rates of items on the belt. And for this, we're going to need, I think, 3 of these. Okay, let's see. While we're here, let's just queue up a few of these in the background. Okay, so we know that here, this is the man on the belt. So we're gonna grab that. We essentially want to multiply by the latency or sorry, divide by the latency. And that will give us items per second, but we really want items per minute so that we can actually see enough, and we can see, because that's what we're using up here, right? We're using science per minute and items per minute kind of here, and we can see how much we actually get out the other side here. So what we want to do is we want to take these, the numbers we're getting here. So each, we're going to multiply this times minus 60. That will get us into minutes. I'm going to do minus because if you remember, our demand is a negative number up here. So I'll put each. Let's see, we need more power. Guess we can stick that there. Okay. And then we are going to divide each of these by the latency. So we can take this output here. Where's our L? L is right here. We can take the L from here into here, and then we can say, give me each, and divide by L, and output each. Okay. And what we can see is that these are actually really low. Look at that. So if we think about it, another way of thinking about it is the full, let's see this. If we say, remember we've got 3% being red science. So if we take 900 times 0.03, that should be 27. Okay, so there's something we didn't quite do right here. So we've got the inputs. We're multiplying by negative 60. And the L is, whoa, the L is way too big here. Is that because we're getting an L in here? It's because we're getting an L in here. That is why. Okay, so this is interesting. So what we actually need to do is we need to screen. We don't want the L coming in here. And we've put it on the red circuit. And so that is because, okay, here's what we actually want to do. Let's take this off. What we actually want to do is, here's the output here. The output does not have an L on it. So that means I think we can come back like this. Okay, this will work. Okay, so we'll say, and here's the L is 376. Okay, so we can say each times negative 60, output each. Okay, that looks better, and there's no L. Okay, here's the 376 that we're outputting here. So we can also, sorry, we'll grab this to here. And we'll grab this to, actually let's do it this way. Disconnect this. We'll grab the L from here with the green wire. Okay, and then we'll grab all of these in here with the red wire. Okay, that looks better. That looks better. Okay, so we can see the actual science per minute we're going to get is actually 20 science per minute, which is here. So that's good to know. So let's just mark this as R. There we go. So these will be the rates that we're actually going to get of things through the belt. Okay, that's good stuff. All right, let's come over here. We are going to want to fix our mining blueprint. And, oh, we do have this set to enable disable. Okay, so let's go ahead and we need to get these red and green wires over here. So let's paste these in. Okay, we can hop these down to here and here. And this is one here. All right, do we have, we are not getting our red wire in here. There's our red wire. Ah, we're missing it right here. Let's connect the red and green. This is going to be one of the main things we're going to do, is making sure we have the red and green wires connected for things. We're going to need more wires. Okay, so we'll build those in the background, which probably means we'll need more green circuits. So we'll build those in the background too. Okay, so do we have the signals coming through here? We do not. Do we have them here? Yes. Do we have them here? Yes. Okay, so that's because we got, this is a different system, so we have to hop them across here as well. Okay, now we have them here. We need these power poles here. Might as well fill these all in. Okay, we got our signals coming through here. We have to hop them down here for the stone. Okay, that means we can paste these here. Okay, signals are coming here. Let's see if we can, will this reach like this? Does not reach. Okay, that means we need one of these. Almost reaches. Plug the red and green wires. Okay, now we're getting signals in here. Okay, good stuff. All right, let's get, all right, so let's actually take a look at this. Let's change this to miners. Okay, so we can see we need 3.3 mining drills. But we also know that we're getting less throughput here. So let's do a little math. 3.3. We actually need to increase that times 125 divided by 100. Remember, we added on some more coal for what we wanted, so that would be 4 miners. But we want to do times 20 divided by 45 because those are our rates, and so 2 miners should be enough to cover us. Okay, so let's get these in here. All right, those are going to fill these up here. We're going to set this here to coal. Okay, so we're going to look for the demand being coal. And if we take a look at this, we want 354 coal on the belt. There's nothing on the green, so this should be enabled, right? It says waiting for source items. Okay, so the first thing that we can do is we can rotate this and begin putting things on. And hopefully, we are not counting. This is no good. See, this is why we have to debug this stuff. All right, the memory cell is not working right here. So let's take a look at this. I have a suspicion I know why it's not working, which is that I think we need this wire in there. But let's just make sure we're getting a pulse read. We're reading hand contents off of this guy, which we are not. Okay, so that was the issue. All right, so we are going to want to, here, let's put this back. Put this back to the signal of this. And then we want to re-blueprint this. Okay, so let's get rid of this one. Thank you for your service so far. We're gonna want these guys. We're gonna get rid of these. So I'm right-clicking on the blueprint here, and that removes certain things from the blueprint. We said we want snap to grid relative. The width we said is gonna be 4. And we need to offset this by 4. The height is going to be 7. We're going to offset this by 7. Is that right? Nope. How about 4? That's right. That's what we want. Okay, so that's tiling right. Okay, good. Now this is disabled by control behavior. which is correct because we don't have this. Let's put this back here. Now it's enabled again. All right, so let's see if this is working. Okay, we're now counting up with coal. We can see it on the green side. Good stuff. All right, let's come over here. And now let's work on the demand side. So I think the first thing we want to do is we want to be correctly grabbing things for power over here. And hopefully we're seeing all our signals coming through here. Yes, we've got the L, we've got all the demands, we've got the count. Okay, this is good stuff. All right, so let's come up here. We're going to do some calculations up here. So we are going to make this work in the following fashion. What I want is I want to actually get some coal into a buffer here so that we can pull from it as we go. And so in order to do that, we're going to get a filter inserter. I'm going to turn it sideways. And the idea here is I want to keep some amount of coal here because, and here's a good illustration, right? Like we're putting coal on. Coal is currently on this section, right? But it's not over here or over here or over here. So there's kind of there's no control other than like the total number of items on the belt as far as, where things on the belt are. We're continuing to count up, so that's good stuff. And so this will, keeping a little buffer in here, it can help us smooth things out. And so I think what we want is we want to be able to run this machine for as long as it takes for a full round trip, because by the time a full round trip happens, we should have seen stuff that's on the belt for us to begin picking things up. Okay, so I'm going to use another mod, which is the rate calculator, and I'm going to take a look at this. Okay, and this says that this thing consumes 27 coal per minute when it's running full speed. Okay, so we are going to grab this and we're going to write that down. All right, so I want 27 coal per minute. Okay, so now the question is, all right, if I want to, if we remember, we got the L here, 376. So the question is, how much coal do I need to consume 27 coal per minute over the course of 376 seconds? And so that's some pretty straightforward math, which looks like, give me the coal. And I'll do each here just because it shouldn't really matter what the inputs are. Okay, so this tells us we want 27 coal per minute. This says how much, no wait, this is not right. I don't want it times 60, I don't think. No, I don't want it times 60. What I actually want is, I want to connect the red wire here. Okay, so what I actually want is, I actually want to multiply this, I think, by the latency. Input signals. That's not right. What I really want is just the L. Okay, so let's fix this. All right, so here's one way to filter things, which is take L plus 0, output L. Okay, and so that just gives us the L. Then we can take that from here to here. Okay, and now we see we've got 10K. And now I think what we can do is we can say for each, divide by 60. Output each. Okay, and that gives us 169 coal. So let's just see if that works out. So if I have 169 coal, and so how long will that last me? And I burn it at 27 coal per minute, then that gives me minutes. And then if I want seconds, I multiply by 60. And that gives me 376 seconds, right? And that is, in fact, the latency that we're seeing here. Okay, so that's right. So what this says is if I want to put 169 coal in this box, and that will let me run continuously for a full round trip. And we're actually computing that, because we're computing L based on, if you remember, the belts that we're putting in. So as we update the overall system with the number of belts, we are going to get this here. So now the question is, okay, we want to do something similar here with figuring out, should I be putting stuff into this box? And I think what that means is we actually want this to be -60 again. So we want to represent this as a demand. Okay, so that gives us this demand of -169. So we can route that in here. If we also connect this box in here, okay, now the inputs are, I got 0 from here, I got -169. And what I can do is, we're going to need this when we have multiple ingredients. So what I actually want to do is say, whatever I'm getting, multiply it by -1. Okay, and that should give us a positive coal signal, right? And so essentially what we're doing is we have 0 times -1 is 0. The -169 times -1 is 169. And when we add those together, we get a positive number if there's less in the box than the demand that we want. And so what we can do from here is we can say, okay, I'm going to feed this here. I'm going to use that to not enable disable, but rather to set filters, right? So it tells the filter inserter, what should you pick up? And it will only pick up items that we're short on in our buffer. So that looks okay. And then the last thing we need is we also need to update our counts, right? So when the filter inserter picks something up and puts it in the box, we're removing it from the belt. And so we will do a pulse, right? Read hand contents pulse. So when you pick things up to take it off the belt, tell us about it. This guy will say, we're going to make it -1 since we're removing from the belt. And then this output gets attached to the green network, which is here. Okay? So I think that's what we want. I think what this will do is we should be, let's watch here, as we pick things up, we are in fact, we can see the green counter flipping a little bit, right? Because as we pick something up over here, we are also, if we come down here to look at it, we're also enabling this one down here to replenish the coal we're pulling off. Okay, so that I think is working the way we want it. So now let's do another one of these. So let's copy this stuff. Let's see. This is not quite right. I guess I can do it down here. Oh, I need another filter inserter. This is fine. Feed that in there. We're going to turn this one. I guess if I put this I guess I want to put this further up here so I can power it like this. Which means I need to run things this way. Okay, then I need one of these, which I need to build. Copy this. Okay, so we're going to get the contents of the box into here. We can actually reuse the green demand from here. Right, and so if you look, that's actually okay, because what's coming in on the green is the minus 169, which also shows up here. And so this one wants 169. This one wants 6, right, to fill out its buffer. So this is working correctly. So then we'll use this to come in here. We'll copy these settings. Okay, so now I'm setting filters, pulse. And then when I pick something up from here, I should feed that into this one, which is updating our counts. And so I can feed this here, and then I can turn this, and then we'll start filling this buffer up here. Okay, and this one has a full buffer, so the filters are not being set. So that's okay, so we're not filling this buffer anymore, extra is going past. But we are filling this one up here, so that stuff looks good. And in fact, I think just to make things a little easier on this inserter, we'll just run this up here like this. Okay, so that's what we are going to do in order to make sure that we have enough coal buffered up in here to run. And we can see that we are, as we're pulling things off the belt, we are similarly putting things back on the belt down here, over here. And so those are feeding back into one another. And in fact, as you can see, we're actually hovering short. We're actually pulling things off faster than we're putting them on, because the filter inserter can actually pull coal off faster than the two miners can generate coal. So this guy is going as fast as we're producing the mining for it. So that's okay, but that buffer will fill up eventually. And then we'll have a reliable source of power, which is actually exciting. And since we will now have a reliable source of power, I think it is going to be, we're going to find it's going to be useful to have some radar that covers the entire base here, which this will do right here. Okay, now we can look at anything in the base with the radar. Okay, good stuff. All right, I believe that if we actually come up here and make 2 more steam engines and a pipe, that should give us plenty of power. We can, now that we're not relying on the boilers themselves to be the buffers for coal, because we have them here, we can, this will give us, let's see, this is 900 kilowatts, so for them it should be 3.6 megawatts, right, which is way more than we currently need. So that will be okay. All right, so we should be good on power for a little while. So, all right, this episode we managed to actually be putting things on and taking things off of the belt, which is exciting. And so next episode, I think what we'll do is we will start actually manufacturing stuff. In this case, we'll probably put some more ore onto the belt, and we'll have to start designing production. So we'll probably start with smelting. And so we'll build a smelting array, and we'll have to do a little bit of design to figure out how that is going to work, very similar to what we kind of did up here with the power. We may, when we come back to do the power, we may generate a blueprint for us for how we're tracking the power for the boilers, but that will be a problem for future Mystic Fish. So exciting progress. Let's take a look. Our pollution has shrunk back down again because we basically have not been doing much for very long. In fact, the only thing consuming power at this point is the radar. We will, and we can see the miners have stopped because we have our full complement, 354 coal on the belt, and that's what we want. So the extra is just sort of rotating around, and we'll consume the buffers and replenish them as things go. So far, so good. Sushi build seems to be working. And that's exciting. So, as always, thanks for watching. We'll see you next time. And until then, bye.